Hello, Algebra. Welcome to Chapter 5. Hey, we're going to spend a little bit of time on linear inequalities in this chapter. Okay, so an inequality is essentially something that where we look at like a broad range of numbers. We're not just looking at two things that are equal. We're looking at all numbers that are bigger than some number or less than some number. So these things are called inequalities when you want to have a wide range of answers. Okay, and we're only looking at linear inequalities at the moment. Okay, so what this means is, like, if I have some line, right? If I have some line that I graph, so let me just draw a real quick picture here before I get going. So say I have this line, right? And I only care about the data that's under the line. Okay, so I care about the data that's down here. I don't care about what's above it. I don't care about, maybe I care about the line since I have a solid line there. But when you go to graph inequalities, eventually when you go to the coordinate plane to graph these things, the solution is all the parts that are shaded. Okay, so we're not going to get into this today, but I'm just trying to give you a big picture. When we're graphing inequalities and looking at inequalities, we're looking at a wide range of numbers. Well, any number that's in that shaded region would be the part of the solution to the inequality. Okay, so that's where we're headed. Don't worry about that too much right now, but let's get into it. So for inequalities, just a real quick review. Okay, that notice that if you tilt your head just a little bit, hopefully you can see this, that the less than sign looks like an L. Right? It looks like an L if you turn your head just a little bit. The greater than sign does not. It's a backwards L, right? So less than always looks like the L. That's how I always remember this. But we have less than, we have greater than, then we have less than or equal to, which has a bar under it, or greater than or equal to. Again, just symboled, if it's or equal to, it's symboled with a bar underneath it. Okay, so I was going to go into this a little bit about, like, why do we care about this? So you can read through some of these examples. You'll have some word problems that kind of lay out, like, when we would use this in life. But for the sake of time on this video, I'm just going to kind of keep cruising here. So set builder notation. This is something that I want you to be familiar with because you'll see this more and more in your book. So I do want your answers in set builder notation. And how this works is it's just saying, like, how this is read is it's the set of all numbers x, that's being this piece right here, such that, that's this bar right here, x is greater than 20. Okay, notice that the variable is always on the left. All right, so we're going to do some switching around here today when we solve some of these. Sometimes when you solve it, you'll have something like this, where the variable's on the right side. The important thing to remember, okay, just as a preview, is that this inequality sign should always, if you think about that, like if you learned it in elementary school, that's an alligator and the alligator eats the bigger number or whatever, just remember the alligator has to stay eating the same thing. So here, if you think about this as an alligator mouth, it's eating the x. If you want to rewrite this in set notation, you would say the set of all numbers x such that x is greater than 3. So notice that thing changed, but it didn't change anything about it because the alligator is still eating the x piece, right? So I switched the x and the 3, but then I also switched the inequality. Hopefully that's making sense to you. It'll make more sense with some examples here. So example 1a. Okay, so for example 1a, what do we do here? Well, we follow the exact same things we did in the beginning of the year here in Algebra 1, where we solve the equation, and we don't really worry too much about the inequality sign. It just becomes part of it. So to get the goal of algebra is to get the variable by itself, right? So we want this m by itself. Right now, 8 is being subtracted from m. So if I want to get m by itself, I have to add 8 to this side of the inequality in this case. I would typically say equation there, but this is an inequality. So I'll do it to both sides. Okay, so when I do that, here it goes away. Okay, keep your inequality sign the same for now. And here I get 30. Okay, so if I want to write this in set builder notation, and you know, example 1, they may or may not make you do that, but I still think you should get used to it. This would be the set of all numbers m, where m is less than. Notice that the alligator is eating the 30 here. Here it has to eat the 30 as well. So set of all numbers m, where m is less than 30. Let's look at 1b. Okay, so for here, we want to get this d by itself, so we're going to add 14 to both sides. Okay, so this goes away. So I have d is greater than or equal to negative 19 plus 14 is negative 5. Okay, notice my variable is on the left, which is where I want it. Okay, so for this one, it's very simple. You would just say the set of all numbers d, where d is greater than or equal to negative 5. Let's move into example 2. Okay, so for example 2, same deal here. If we're adding something, we have to subtract it to get it by itself, right? So if I want p by itself, I got to subtract 8 from both sides. So this goes away. I have p is less than or equal to 18 minus 8 is 10. Okay, so since my variable's on my left, I'm good. I don't have to move anything around. So my final answer is p, all set of all numbers p, where p is less than or equal to 10. All right, let's keep cruising. Example 3. So now what they want us to do is they want us to graph this on a number line. So notice in the beginning of the lesson I talked about a coordinate plane. We will get there, but now we're just going to look at the number line. Okay, so this says solve, then graph your answer on the number line. So here, there might be a couple of two-step types of equations, but hopefully not too many of these. So what we want is we want all of our variables on one side, right? And then we want to get the variable by itself. So here's what I'm going to do. I'm going to move the n's to one side. Instead of getting rid of everything on the right side of this thing, I'm going to move the 9n over. To do that, I'm going to subtract it, because right now, I don't want to separate these two things. Okay, I just want this one piece, which is typically, I mean, if there's nothing in front of it, we assume that it's positive, right? So to get rid of it, we just subtract it. So we have subtract 9n from both sides. This goes away, and I'm left with negative 1 is less than 1n. Okay. Now, notice that the variable's on the right side. I want it on the left side. Okay, there's a 1 there with the n. Not a big deal. It's the same thing as just n. So what I'm going to do is I'm going to rewrite it, and I'm going to say the set of values n, where n, and notice the alligator ate the n, is greater than negative 1. Okay, so how do I show that on a number line? Well, on a number line, there's two types of things that we're going to look at today. We have open circle and closed circle. Okay, if I have an open circle on a number line, that means not included. Okay, this is anything that has a less than sign or a greater than sign. With a closed in, that means it's included because it's less than or equal to, right? Or greater than or equal to. Okay, so that means that it could equal the number that it's on. So here, we're not included because we don't have a bar underneath our greater than sign. Okay, so at negative 1, we're going to have an open circle. And it's saying that n is greater than this. Okay, if you always solve it so that the variable's on the left, this inequality will always point in the direction you go in your number line. But you could also just think about it, right? It's the values that are bigger than negative 1, so that would be all of these numbers, all the way to infinity, in fact. Okay, so that's how your graph should look. For example 3b, let's do the same thing. Let's get all the h's to one side. Okay, that goes away. We're left with just one h here is less than or equal to 12. In set notation, that would be the set of all numbers h, where h is less than or equal to 12. Notice I don't have to switch anything around because my variable is on my left. Okay, so it's saying that the variable here, h, just represents the unknown numbers, right? All the part of the solution or the unknown solution is the numbers that are less than or equal to 12. So that is now known. So at 12, we fill in the circle because it says or equal to. Okay, and it's all the numbers that are less than or equal to it. So we're going to go this way on the number line. Okay, that's example 3B, and that is all we have for today. Okay, so there's some homework problems that are posted here, but I'll have a homework sheet for you. We'll catch you guys next time.